Imagine throwing a tennis ball at a wall. You know roughly where it will land and how it will bounce. For hundreds of years, scientists believed the entire universe worked like that, predictable, orderly, and completely understandable if you knew enough information. Then, in the early 1900s, scientists began studying incredibly tiny particles like electrons and photons. What they discovered completely changed our understanding of reality. Welcome to quantum physics. Quantum physics is the branch of science that studies the smallest building blocks of nature. Instead of planets, cars, or people, it focuses on atoms and the particles inside them. At this tiny scale, the rules of everyday life no longer apply. One of the strangest ideas is called wave-particle duality. Imagine a tiny particle of light called a photon. Sometimes it behaves like a tiny ball. Other times it behaves like a wave moving across water. It isn't switching between the two whenever it wants. It naturally has properties of both. The same is true for electrons. Scientists proved this with the famous Double-Slit Experiment. If you fire tiny particles through two narrow slits, you would expect two neat lines on a screen behind them. Instead, when nobody measures which slit each particle passes through, they create a wave-like interference pattern, as if each particle somehow traveled through both slits at once. But when scientists measure the path, the interference disappears and the particles behave normally. Observation changes the outcome. This doesn't mean human thoughts magically change reality. It means that measuring a quantum system requires interacting with it, and that interaction affects what happens. Another important idea is superposition. Imagine flipping a coin. Normally, it's either heads or tails after it lands. In quantum physics, before measurement, a particle can exist in multiple possible states at the same time. Only when it is measured does one outcome become definite. This concept inspired the famous thought experiment known as Schrödinger's cat. Imagine a sealed box containing a cat and a device controlled by a quantum event. Until the box is opened, quantum mechanics suggests the system can be described as containing both possible outcomes together. The story wasn't meant to say cats are literally both alive and dead. It was created to show how strange quantum ideas seem when applied to everyday objects. Another surprising phenomenon is quantum entanglement. Two particles can become linked so that measuring one instantly tells you something about the other, even if they are separated by enormous distances. This doesn't allow faster-than-light communication, but it reveals that nature is more deeply connected than classical physics predicted. Quantum physics also introduces the uncertainty principle, proposed by Werner Heisenberg. It states that there is a fundamental limit to how precisely certain pairs of properties, such as a particle's position and momentum, can be known simultaneously. This isn't because our instruments are poor, it's a basic feature of nature itself. These ideas may sound bizarre, but quantum physics is one of the most successful scientific theories ever developed. It accurately predicts experiments to an astonishing degree. More importantly, quantum physics isn't just theory, it powers much of the modern world. Transistors inside every computer and smartphone rely on quantum mechanics. Lasers, MRI scanners, LED lights, solar panels, and many modern technologies exist because scientists learned how quantum particles behave. Today, researchers are building quantum computers. Unlike ordinary computers that use bits equal to either 0 or 1, quantum computers use qubits, which can exist in superpositions. For certain specialized problems, this could allow enormous speedups over today's computers. However, quantum computers are not expected to replace ordinary laptops for everyday tasks. Despite over a century of research, quantum physics still raises profound questions. Why does measurement produce a single outcome? Which interpretation best describes reality? Scientists continue to debate these questions while agreeing on the mathematical predictions that experiments confirm. The biggest lesson from quantum physics is that the universe is stranger than our everyday experience suggests. The microscopic world follows rules that challenge intuition, yet those rules consistently describe reality with extraordinary accuracy. So the next time you use your phone, switch on an LED light or undergo an MRI scan, remember that behind these everyday technologies lies a world where particles act like waves, probabilities shape outcomes, and the universe behaves in ways that continue to surprise even the world's greatest physicists.